Today we're going to talk about piecewise functions. Until now we've discussed functions with only one equation. However, in real life, functions sometimes can be represented by a combination of equations with different rules for different parts of the domain, and these are called piecewise functions. Let's look at an example. I've got f of x equals 2x minus 1 whenever x is less than or equal to 1. And I've got f of x equals 3x plus 1 whenever x is greater than 1. What this is saying, whenever I have an x less than 1, or 1, like 1 or 0 or negative 1, I'm going to use the first function, 2x minus 1. If I have an x bigger than 1, say 1.5 or 2 or 3, I'm going to use 3x plus 1. So what we're going to do is break this into pieces and graph each piece separately. So we're going to set up t-charts for each one. Now, when you're getting ready to graph these things, it's real important for you to pay attention to how the boundary is stated. So, for example, in the first function, f of x equals 2x minus 1, I've got x less than or equal to 1. So what this is saying, my inputs will begin at 1 and include all those that are less than 1. So when I set my table up, I'm going to use that as my first input. I'm going to use a 1. If I input a 1, I have 2 times 1, which is 2, minus 1, which is 1. So I have the point 1, 1. Then I want to pick an x less than 1, so I pick 0. 2 times 0 is 0, minus 1 is a negative 1. Now I have enough to graph my line. Now when I get ready to make my first point, I pay attention to the inequality. I have here a less than or equal to, so that means it includes the 1, so I use a closed dot at the point 1, 1. Then I have to graph the point 0, negative 1, which is pretty easy. I go down here and put a dot at 0, negative 1, and I get ready to connect my dots. Now, I want you to notice, when I connect my dots, this says this function is true whenever x is less than or equal to 1. So when I draw my line, only one end of the line is going to have an arrow. That's because this function is defined only for x's beginning with 1 and a less than 1, so 1, 0, negative 1, negative 2, and so on. It's not defined on the right-hand side, so there's not going to be an arrow on that side. Now let's look at the second function. Again, you pay attention to your boundary. This says this is true whenever x is greater than 1. So our first input will be the 1, so I input a 1. 3 times 1 is 3, plus 1 is 4. This is going to be a good indicator as to how to start building your table. So always begin by looking here at how the domain is stated. Now I want an x that's bigger than 1. So you can pick anything bigger than 1. I just chose 2. 3 times 2 is 6, plus 1 is 7. So I have the point 2, 7, and that's enough to graph my line. Now this says it begins at 1 but does not include 1. So instead of a closed circle for 1, 4, I'm going to use an open circle at the point 1, 4. Okay, my second point is 2, 7, so I go and make my point at 2, 7. And then again, I get ready to connect the dots. And again, I'm not going to have a line with an arrow on both sides. This begins at 1, 4 and continues for all x's that are bigger than 1. So the arrow is only going to be on the top-hand side. And that's how you graph this piecewise function. Let's look at another one. This one is very similar, except instead of having 2 parts, it has 3 parts. But the way that I approach it is going to be exactly the same. So we'll look at the first function. Again, I'm going to pay attention to how my domain is stated. This function is true whenever x is less than or equal to negative 2. So that means I'm going to begin by selecting an x that is equal to negative 2. If f of x is negative 2, if f of negative 2, I plug it in, I'm going to get a 1 to come out. And again, I want to choose an x that's less than negative 2, so I could pick a negative 3. If I plug in negative 3, again, a 1 is going to come out. So I've got the point negative 2, 1, and negative 3, 1. Now again, you pay attention to the less than or equal to. That or equal to means I use a closed dot. So I use a closed dot at negative 2, 1. And then I use another closed dot at negative 3, 1. And I get ready to connect my dots. This is true only for the inputs that are less than negative 2. So I'm going to begin at negative 2 and go all the way to the left and use an arrow here. So that takes care of the first function. Let's look at the second function. Remember, when you're setting your tables up, you're paying attention to the endpoints, to how the domain is stated. This says this is true for all x's between negative 2 and 3. So f of x equals 2 plus x whenever x is between negative 2 and 3. So again, that's how we're going to start our table. We should start with a negative 2. It begins at negative 2. If I plug in a negative 2, 2 minus 2 is 0. I only need 2 points for my line, so I might as well pick the endpoint of 3. So I plug in a 3, and 2 plus 3 is 5. Now again, I pay attention to the inequality. This is less than x, so I want to use an open circle at the point -2, 0. And then for the point 3,5, I've got less than or equal to 3. So I go over here, I use a closed dot at 3,5. Then I get ready to connect my dots. Now here, we're not going to have an array or a line with 2 arrows. It begins at -2 and ends at 3. So we're going to have a line segment. So our line will look something like this. Okay? It has a definite beginning and a definite end. It begins at -2 and it ends at 3. So now we'll look at the third one. The third one begins at 3. So again, I'm paying attention to how the domain is stated. It says that it's true for all x's greater than 3. So that means my first input will be at 3. 2 times 3 is 6, so I get the point 36. I picked some x greater than 3, so I chose a 5. And 2 times 5 is 10. So then I get ready to graph. I pay attention to the inequality. It's a greater than. So I need to use an open circle at the point 36. So I go up to 36. And then I want to plot the point 5, 10. So I go over here and I plot the point 5, 10. And then I get ready to connect my dots. It begins at 3 and goes out to positive infinity. So one end will have an arrow on it. And the graph will look something like this. And this is my second piecewise function. So here, the way that we work this is exactly the same as the other. The only difference is I had 3 pieces instead of 2. And that happens occasionally. Now let's look at another example. This one is absolute value. Now in Algebra 2 we studied absolute value, and you studied it also in Algebra 1. An absolute value in reality is just a piecewise function. If we think about the absolute value, f of x equal the absolute value of x as being f of x would be negative x if x is negative, or f of x will be x if x is positive. We could break it down into 2 separate equations. So let's go ahead and do that. Here, if x is less than 0, this tells me start with 0. So I'll put a 0 in. So in this function, f of 0 would just be 0. And then I want to pick another x that's less than 0, so I could pick -1. And if I plug in -1 here, I get a 1 to come out. So let's look at this. This begins at 0 but does not include 0, so I'm going to use an open dot at 0, 0 for my first point. And then I have the point -1, 1. So that's my second one. And then I can go ahead and connect my dots. It begins at 0 and then it goes on out to positive infinity this direction. So that's the first function. Now I'll look at the second function. It starts where x is greater than or equal to 0, so I start with 0. I plug a 0 in here, I get 0 to come out. And then I pick another x greater than 0, so I could pick 3. If I plug a 3 in, 3 is going to come out. So I pay attention to the inequality. It's the greater than or equal to, so I have a closed dot. The closed dot always will override the open dot, and that's okay. You can have a dot on top of another dot. And then I have the point 3, 3. So I pick up the point, and I go out to the point 3, 3. And then I connect that. And I now have my absolute value graph. Now, if you will remember from Algebra 2, if I have an f of x equal to an absolute value over here, it's going to be a V shape. And remember, if the sign in front of the absolute value is positive, it should open up. If it's negative, it will open down. And that will kind of help you in your graphing to pay attention in case you see an error somewhere. Let's look at another example. Here I'm going to graph this, but instead of breaking it into 2 different equations, there's a quick way that you can do this, and it's a lot quicker and a little bit easier to do. And what we can do is we can focus on what's inside the absolute value. What you want to do is take whatever is inside the absolute value and figure out what would I need to input for x to make this absolute value equal to 0. And when I do that, that's going to help me find my vertex, which will be either your low point or your high point in your graph. And then we'll pick numbers around that vertex to help us figure out which way the absolute value is going to be opening. So let's look at this one. I want to figure out what will make this x 0. So this is pretty easy, just 0. So I'm going to let x be 0. If x is 0, I have 2 times 0, which is 0, minus 6. I get a minus 6 to come out. And this is going to be my vertex. Okay? Then I want to pick an input that is less than 0. So I could pick -3. And then I'm going to input the -3 and see what comes out. So if I want to find f of -3, we'll go ahead and do the work here just so you can see. I have 2 times the absolute value of -3 minus 6. And the absolute value of -3 is 3, and 2 times 3 is 6, so I get 6 minus 6. So I'm going to get a 0 to come out, so that should be 0. Now I picked an input that was less than 0. I need to pick an an input that's greater than 0. So, and I just chose a 2, and I'm going to plug that in and see what comes out. So let's find out what f of 2 is, just make sure we do our arithmetic right. So I have 2 times the absolute value of 2 minus 6, and then 2 times 2 is 4, so I've got 4 minus 6. So I should get a negative 2 to come out. Okay, and then I want to plot my points. Now, for these, I'm not going to worry with the open circle. These are all going to be closed circles. So go down here and I'll plot my vertex first at 0, negative 6. And then I'll plot the point negative 3, 0 would be here. And I'm going to plot the point 2, negative 2. So here's 2, negative 2. Now, I know this is my vertex, so when I get ready to draw my graph, I'm going to start by beginning at the vertex. This one's going to go up toward this point right here. And I go back down to my vertex and go toward the other point here. And there's my absolute value. It is V-shaped. It is opening up. Since A is positive, it's a positive 2. It's that easy. Let's look at one more absolute value. This one looks a little difficult, but it's not. It just has the fraction in it, and I think we can handle that. Remember, when you're getting ready to graph these absolute values, there's all kinds of cute little tricks that you can use, but the easiest thing to do is figure out what would I need to input here to make this expression 0. And it's quite obvious that if I plug a 3 in here, 3 minus 3 is 0, this whole thing will go away. So I'm going to use 3. If I plug in a 3 here, a 1 is going to come out, so my vertex is at the point 3, 1. So I'm going to go ahead and plot that. This is going to be my turning point, 3, 1. So either I'm going to go up or I'm going to go down from this point. So let's see what happens. I want to pick a number that is less than 3, so we'll pick one that's less than 3, and I chose a 1. And I did so just so that the math would be pretty easy, because I noticed that 1/2 in front, so I have a 1/2 times the absolute value, and I know that 1 minus 3 is 2. So that's going to help me not have to deal with a fraction anymore. So I look here, I've got 1/2, and I've got the absolute value of a negative 2 plus 1. So half of 2 is 1, so I've got 1 plus 1, so I should get a 2 to come out. So when I'm picking something to plug in here, I want to make it so that it's divisible by 2 to make the math a whole lot easier. That's why I chose what I chose. Now, let's look at the last one. I want to pick something, let's see if I can get that to go away. Pick something bigger than 3, and I want to choose very wisely, so I'm going to choose a 5, because I know that 5 minus 3 is 2. So 5 minus 3 is 2, half of 2 is 1, and 1 plus 1 is 2, so I've got 5, 2. I'll plot the point 3, 1. I'm sorry, 1, 2, and then I can plot the point 5, 2, just like that, and I can draw my line. So starting with the vertex, I go up this direction to the other point, and then from my vertex, I go this way, and now I have my absolute value graph, and that's it. So graphing piecewise functions is pretty easy. You just look at it piece by piece. Sometimes the graphs connect and sometimes they don't. So go ahead, go back and look at this and study it, and let me know if you have questions, and I will see you in class.